800.
Okay, so guys, we're going to work on doing some exponent stuff.
Wow.
Exponent review, and what we're doing is we're talking about the rules, all right, so we can get those down. I'm probably going to try to draw a little, maybe write a little smaller, so because I'd like to get all this on one page. I think for graphic organizer's sake, having everything on one page is really handy. All right, now Jason, I'm going to start with what we were talking about the other day, and you can correct me if I make any mistakes or if there's anything I want to add. Whoops. So today's the 26th, so I always like to date my, my stuff. Okay, so first thing I'm going to put up here is that we have, let's say we have a 26x to the third. That 26 is my, we call it a coefficient, but I'm going to change that name and I'm going to call it the number of x to the thirds. So a lot of people forget that that is 26 of the x to the thirds. Because nobody remembers a coefficient. That's just a fancy math term that a lot of people struggle with. All right, so we have the x, that's called the base. Or we can call it the variable. All right, and that third, I'm going to call it two things. That is the exponent. That is the exponent. All right, what it is also is that, I'm going to call that the multiplier. Yep. All right, that is, I know that's really kind of messy, but that's called the multiplier.
Why is this paper dirty? It looks like it was stepped on.
Maybe I stepped on it.
Like my emotions.
I don't know what to say to that. Sorry. All right, when I say multiplier, that's because the x is multiplied by x 3 times. Okay, x times itself 3 times. That's why I call it the multiplier. All right? Now, is that exponent of 3 attached to the 26? How many times do you multiply the 26? Go ahead. Nope.
3 times.
Nope.
1 time.
Yes. There is a 1 for that 26. That 26 has a 1 above it.
So
Okay?
multiply it 1 time.
It's just a 26. 26 times 1. All right? It doesn't change. That is a 26 times x to the third.
But why?
So we could rewrite this as 26 times x times x times x. That is 26 times x to the third. All right, we could rewrite that.
Yeah, but why do you put the 1?
Because it's an implied one. Just like if for some reason I had just, give me a random, give me a letter and give me a number.
7.
7? Give me a letter.
3.
Give me another letter.
B.
B. Okay. Yeah, we know. How many 7s are there?
B.
There's 1 7. So we could put an exponent around that 7. Okay, and that would be a 1. How many B's are there?
1.
Right. So that B is to the first power, but there's also 1 B there, right? I could also say x to the 5th. How many x to the 5ths are there?
1.
Yes, there is 1 x to the 5th. If there's 45 x to the 5ths, how many x to the 5ths are there? 45.
Oh.
Remember, the 45 is the number of
Okay, yeah.
variables.
Now I get it.
Does that make sense?
So, yeah. Yeah, because there's, yeah, so if there's 45,
Yes.
x to the 5th, then there's 45, and there's nothing. It's on-
If there's not a 1 there, if it's just x to the 5th, there is an implied 1 in front of it. The coefficient is 1. Because if you multiply anything by 1, it stays itself. Right? Does that make sense?
Yeah.
Okay. Ryan, give me another letter.
R.
Okay, good. Nice. All right. So, moving along. That is just some background. What I want to talk about, and I'll use my blue pen for this, all right, I want to talk about the 0 power. What does the 0 power mean? Give me an example of a 0 power, Dale. Why don't I do this? I'm going to write your 2x to the 3rd, and I'm going to put that whole thing to the 0 power. Okay, so I put the whole thing in parentheses, all right, and I put the whole thing to 0 power. All right, I'm going to come back to that one. All right, I'm going to give you some more examples here. I'm going to say x to the 0 equals, I'm going to say 27 to the 0 equals, I'm going to say x squared y to the 0 equals, and I'm going to say 2x to the 0 equals. These all are examples of having a 0 power. All right? In different places there are zeros as the exponent.
Is that Y?
No. It does not, yes. It does not equal 0. And I'm going to show you why. Okay? Give me an example. Can we break down x to the 4th? Break that down for me. Go ahead, Iris. Yeah. X times itself 4 times, right? All right, we have x to the 3rd is x times x times x, right? X squared, x times x. So what's happening to all these?
Breaking down.
They're reducing by 1. 4, 3, 2, 1. X to the 4th, x to the 3rd, there's 3 of them. X squared, there's 2 of them. X to the 1, there's just an x, just one x. X to the 0, all right? X to the negative 1 is 1 over x. X to the negative 2 is 1 over x squared. X to the 0 is a big 1. Anything to the 0 is a numeral 1.
Everything.
Everything to the 0 is a 1. So x to the 0 is a 1. 27 to the 0, 1. 2x to the 3rd, all of it to the 0 equals 1.
The whole thing's 1.
That whole thing is to the 0. Now this is where it gets a little tricky. This one, there are 2 variables. One of them has a squared, one of them has a 0. What do you think, Iris?
So you would do like your x squared and then your y to the 1, or 1.
Yeah. The y to the 0 turns into 1. The x squared stays x squared. We're not doing anything to the x squared. So it becomes x squared. You could do x squared times 1.
Do you have to do
It's 1 over x squared. Do you have to put the 1? No. Because anything multiplied by 1 is itself. The 1 is implied. Okay? What about this one here? Patrick, what do you think? What happens to this? remember that this 2, remember that this 2 does have an exponent. What's the exponent above this 2? The exponent above this 2 is a 1. Remember, that 1, that magic 1 in math, you can throw a 1, 27 times 1 is 27. 27 over 1 is still 27. You could throw the 1 around in certain places and it doesn't change, right? 36 divided by 1 is still 36. So that 2 has a 1 over it, the x has a 0. What happens to the x that has a 0 exponent? No? What happened to this one? X to the 0 turns into 1. So what happens to this one? Yeah. So this ends up being 2. Well, because the 2 to the 1 doesn't change, just like the x squared doesn't change that Iris told us about. The 2 to the 1, yeah. You could write 2 times 1, which just equals 2.
So if that was a 3 instead of 2, it'd be 3.
Wait, if what was a 3 instead of a 2?
This is a 3x.
To the 0, it'd be,
Oh, right, yeah.
it'd be the same
A
thing.
3x to the 0 equals 3. All right? A 457x to the 0, y to the third equals what? Go ahead, Iris.
I actually, like, if you did 2 times 1 on a test and you didn't do equals 2, would you get it wrong?
The answer is 2.
So if you just did 2 times
Oh, yeah.
1.
If you just did 2 times 1, if it was, no, I'd probably give it to you.
Like, would you get it wrong?
I'd probably give it to you. So, Jason, what does this turn into?
It's 457.
457.
Y to the third.
Y to the third. Awesome. Because the x to the 0 turns into what, Patrick?
It's the same number.
What does that mean?
Wait,
X to the 0 turns into what? X to the 0 turns into what? Anything to the 0 turns into what?
1.
Yeah, you did it here, you did it here, you did it here.
If that has a 0 over the x, it's the same number.
If anything in this world has a 0 exponent, the answer is 1. If you have a cow to the exponent of 0, it turns into a 1.
And then you move. Because that's what you do, but it changes.
That's fine.
So if you just have a number with, or like 27 with a 0, it's going to be 1, but if you put like a value in, and then a 0, then it would be the number.
Okay, you're writing 357.
If this was, okay, if this was 457 to the 0, x to the 0, y to the third, what does that end up being?
End up being the same number, just 1 to the third.
It'd be.
Anything. Any base to a 0 power, there's no way I can keep this on one page, becomes a 1. Anything to the 0 power becomes a 1. So, what does this one turn into? 457 to the 0. x to the 0, y to the third turns into what, Natasha?
What?
457 to the 0, x to the 0, y third. Y to the third. Why? Anything to a 0 power becomes a 1.
Yeah.
What's to a 0 power? Which ones have a 0 power? 457. What does that turn into? What does x to the 0 turn into? What does y to the third turn into?
3. I don't know.
Go ahead, Rye.
So 457 x, no, 457 y. 3.
Natasha, what does 457 to the 0 turn into?
1.
What does x to the 0 turn into?
1.
What does y to the third turn into?
1. No. I didn't write it. 3.
Okay, let's look at it this way. X squared, y to the 0. What does that turn into? X squared. Because that doesn't change. So, Ryan, what does 157 to the 0s turn into? Ryan, read this to me.
It's 1, but it's going to be 157.
No.
How is it not?
27 to the 0 is a 1. How are you guys not getting this?
Wait, I know.
I know, but it's the kids that don't, I need them to process through
I
it.
understand it, but
Ryan, 27 to the 0 equals 1.
yes, I know.
So what does 457 to the 0 equal?
1,
What does x to the 0 equal?
1,
What does y to the third equal?
not 1.
What does it equal?
3. 457. I don't get what you're asking.
I'm asking you, what is the answer to this? How can you simplify this line? All right, I'm gonna tell you.
You
Is
have
it
to hold this
450?
Go ahead, Iris.
Okay. If you have, if it's like, because there's 2 1s, do you make it into 2 or is it just still 1?
What's 1 times 1?
1. I'm just kidding. Okay, so it's 1 y to the 3.
Yeah, or you could just write y to the third.
Oh.
I don't want to tell you, I want you to learn.
Never figured that out.
Ryan, think about it. Think about it. If 27 to the 0 equals 1, why doesn't 457 to the 0 equal 1? And Natasha had already said that that equals 1.
What? 457?
457 to the 0 equals 1.
May I use that?
Anything to the 0 power equals 1.
Yes, I get that.
Okay, Ryan, you're going to do this one. Yes, you can go to the bathroom. Okay? All right. Let's do this one, Ryan. 6x to the 0. Now, let's do 6 to the 0, x to the 0, y to the 0, z to the 25th. What's the answer, Ryan? Yes. Z to the 25th.
Woo!
I think we got it. You with me, Natasha?
Yeah,
Okay.
go to the bathroom now.
So much work?
Yes. It is hurting my bladder.
Okay. Give me a letter.
R.
All right, guys. That is the 0 power. Okay? Remember, this should be review.
Well, we haven't learned this.
Yes.
Yes, you have. I've seen your notes. I've seen your notes.
Yeah.
Yes. So here's the thing. If Patrick, if this is on the final exam, all right? That's why I'm going over it. It's on your final too. So if this is still not understood, write down a question for me, all right? So I can help you understand. Or you could you could skip this part in the exam. That's okay too, if you wanted to focus your effort on linear equations or on the geometry, whatever you want to do. All right? Next up is the multiplication rule. All right? So for multiplication, You have to have some sort of multiplication power. All right? So let me give you an example. Like x squared times x to the third. Okay? This one has two different bases that are multiplied together. All right? The first thing I have to do is, in my mind, I want to break this down. How can I break this down, Jason?
Can't you do two x's, so on the bottom?
I can. What do you mean by two x's?
So, 1x and then times.
Yes. So x squared equals x times x, right?
Yeah,
And then I got to bring in the times sign.
3 more.
And then x times x times x. Okay? This is x squared. This is x to the third. Right? You with me on that?
You technically wouldn't have to put the dot in the middle.
Well, the dot's right there. I wanted to make sure that I was, if you're multiplying x squared times x to the third, I'm going to do x squared times x to the third. Right, Dale? All right, I'm just trying to be consistent. So what does that equal? Ethan, what do you got? What does this end up being when we simplify these? What is this if I do x times x times x times x times x? Look at our breakdown over here. Look at our breakdown over here. Ethan Rawson. X squared is x times x. X to the third is x times x times x. X to the fourth is x times x times x times x. What is x times x times x times x times x? Yeah.
What does that say, multiplication?
X to the fifth. Yep. All right, that's perfect. All right, I can do that again, and I can say y times y to the third times y squared. Can't I? How does that break down, Patrick? Now look at where I got the word breakdown over here. This is these broken down. I broke the x to the fourth down because it's x times x times x times x. Why don't you break it down for me like I did here? Show me the step in between. Break this down. This is this broken down. Y times y times y times y times y. You sure you got them all? This one, I'm going to say is right here, right? Where's this one?
Oh, so you need to add. Alright, so we times another y and then the y.
Hold on. Okay, so I just broke down this problem into all of the y's, right?
What does that mean?
Multiplication. So what does this become, Patrick? Y to the sixth power. That's great. Is there an easier way to go from this to this? There is. Dale, what's the easier, are you with us, Dale, or are you working on your own thing? I wasn't sure. Oh, okay. So how do we get from this to this without doing the breakdown? Is there an easier way? Do you see some sort of pattern? What's the pattern? What's that?
Just add the numbers,
Just add what numbers?
the exponent numbers.
Yeah. 3 plus 2 is 5, plus how many is there? 1? Yeah. So for multiplication, you add the exponents. Okay? So this is y to the 1 plus 3 plus 2, which equals y to the 6th. What you gotta remember though is that this y has a 1 over it, Patrick. Okay? Remember, just like we started at the beginning, with the number b.
You mean the letter B?
No, I meant number b.
No. Did you get to do it at the beginning of class?
No.
He wasn't paying attention at that point.
Oh my God.
All right. Guys, I want you to come up with, no, I'll give you another example, and then I want you guys to start coming up with your own examples. I know Jason started this the other day. I want you guys to come up with your own examples. So I'm going to say, what if I say 2x squared times 3x to the 4th times x. Yeah, how about that?
Whoa.
Challenging, bro.
So I'm going to break this down, okay? I'm going to start by taking the 2 and the 3. Since the x squared and the x to the 4th, they both have the same base, they both have x's, I can take the 2 and the 3 and I can pull those out. I got a 2, and I can do times 3. Okay? Then I can break down the x squared as x times x. I can break down the x to the 4th by x times x times x times x. And I can break down the x that way.
Well, I thought you added
I'm going to show you. So for this one, I have 2 times 3, which is 6. X to the, what do you got, Natasha?
What? I'm not even done writing it down. What do you want me to say?
So I multiplied the 2 times 3 and got 6.
Yeah.
All right, what's the exponent for the x?
5? I don't know, do you count them? Yeah.
Yeah? Go ahead, count them.
7?
Yep. Okay? What we're doing here, all right, is 6x to the 2 plus 4 plus 1. That's the actual process that we're doing. Guys, we don't have to break these down anymore because we know the rule is to add the exponents. 2 plus 4, which is 6, plus 1, which is 7.
Oh, I forgot
6x to
add
the
it.
7.
I just looked up. I didn't even see it, so I just added them. Well, perfect.
Gotta watch. Okay? So guys, I'm going to leave some space for you to put in some more examples. All right, can I flip? Uh-huh. All right, let's do division.
Oh, yeah. Oh, yeah. Oh, yeah.
I'm going to do b to the 4th divided by or over b to the 3rd. Ryan, break that down for me.